Hello and welcome back to the gRPC course. In this lecture, we will learn how to implement client streaming RPC with Java. We're gonna implement an API that allows client to upload a laptop image file in multiple chunks. Okay, let's start. This is a PCBook Java project that we've been working on. The first thing we need to do is to define the new upload image RPC. As we have already done that in the previous video with Golang, I will just open the PCBook Golang project and copy-paste the content of the laptopservice.proto file. Here we have the upload image request message. It has a one-off data field, which can either be image info or a chunk of image data. The image info contains the laptop ID and image type, such as JPEG or PNG. The chunk data is a sequence of bytes. The idea is that we will divide the image into multiple chunks of 1 kilobyte and send them to the server sequentially via the stream. Then the server will send back one single response, which contains the ID of the uploaded image and the total size of that image. So the upload image RPC will take a stream of upload image requests as input and return an upload image response. Alright, let's build the project to generate Java code. The build is successful. Now before we implement the RPC, we will need to add a new store to save the uploaded image. I will create a new image store interface. It has one function, save, which takes the laptop ID, the image type, and the image data as input, and returns the image ID or throws out an I/O exception. Let's say we want to store the image on disk and its metadata on memory. So I will create a new diskImageStore class to implement this interface. In this class, we need a field to tell us where to store the images. We also need a concurrent map to store the metadata of the images. The key of the map is the image ID, and its value is the metadata. I will create a new class for the image metadata. In this class, we will store the laptop ID, the type of the image, and the path to the image on disk. Let's write the constructor to initialize the object. And also create some getter functions for each of the fields. Okay, now go back to our diskImageStore. First, we create a new constructor that takes only the image folder as input. We initialize the data map with a new concurrent hash map. Then in the save function, we generate a random UUID that will be used as the image ID. We make the path to store the image by joining the image folder, image ID, and image type together. Then we create a new file output stream with the image path. We call imagedata.write_to write the image data to that file output stream, and close the output stream. Once the file is successfully written to disk, we create a new metadata object and put it to the data map with the image ID key. Finally, we return the image ID, and we're done with the diskImageStore. Now let's implement the upload image RPC in the laptop service class. First, I will change this store field to laptop store. Then we will add a new field for the image store. Also add it to this constructor. Okay, now we need to override the upload image method. As you can see, this method has a response observer parameter that will be used to send the response to the client, just like the way it works in the search laptop RPC. How about the stream of request? This is very different from the server streaming RPC because it's not an input parameter, but the return value of this function instead. Here we can see that the upload image function must return a stream observer of upload image request. And this stream observer is just an interface with three functions: onNext, onError, and onCompleted. What we need to do is to return an implementation of this interface. So let's do that. First, we define three fields: laptop ID, image type, and image data. Now in the onNext function, we check the data case. If it is image info, we write a simple log saying that we have received the image info. Then we get the laptop ID and image type from that info. We also initialize the image data as a new byte array output stream and return. Else, it must be a new data chunk. So we get the chunk from the request. Write a log here saying that we've received a chunk with this size. And then we check if the image data is null or not. If it is null, it means that the client hasn't sent the image info. So we just send an error with invalid argument status and return immediately. Otherwise, we just call chunkdata.writeTo function to add this chunk to the image data. If we catch an exception, just send an internal error to the client and return. That's it for the onNext function. The onError function is called whenever an error occurs while the server is receiving stream data. So here we just need to write a warning log. Okay, now let's implement the onCompleted function. When this function is called, it means that the server has received all image chunk data. So we just call imagestore.save to save the image data to the store. Surround this with a try cat. If an error is caught, we call responseObserver.onError to send it to the client. We save the output image ID to a variable and also get the total image size. Then we build a new upload image response object with the image ID and image size. We call responseObserver.onNext to send the response to the client. And finally call responseObserver.onCompleted to finish it. Okay, the upload image RPC is ready. Now we need to update the laptop server a bit. First, change this store to laptop store. Add a new image store to this constructor. Then pass it into this laptop service. Do the same for this constructor. In the main function, we also change the store variable to laptop store and create a new disk image store with the image folder is img. Then pass it into the new laptop server constructor. The img folder is already here, so we're all set. Let's run the server. Now let's try to call this server using the Golang client that we wrote in the previous video. The laptop image is successfully uploaded. We can see it in the img folder, so it works. Great. Now we will implement the Java client. We cannot use a blocking stub to call the client streaming RPC. Instead, we will need an asynchronous stop. So let's define it here. And initialize it inside this constructor by calling laptopservice gRPC.newStop. Alright, now define a uploadImage function with two input parameters, a laptop ID and an image path. In the main function, I'm going to comment out this block of code to test the create and search laptop that we wrote in the previous lectures, and add new code to test uploadImage here. First, we generate a new random laptop. We call client.createLaptop to create this laptop on the server. Then we call client.uploadImage with the laptop ID and a laptop JPEG file inside the TMP folder. Let's create that TMP folder and copy the laptop.jpg file from the Golang project to that folder. Alright, it's here. Now in the uploadImage function, we call async_stop.withDeadline after 5 seconds, then .uploadImage. We create a new stream observer of uploadImage response here. The output of this call will be another stream observer of uploadImage request. In the onNext function, we just write a simple log saying we've received this response from the server. In the onError function, we write a severe log, upload failed. Note that the stop is asynchronous, which means that the send request part and the receive response part are run asynchronously. Because of this, we need to use a countdown latch to wait until the whole process is completed. Here we just use a count of 1 because we only need to wait for the response thread. Okay, now if an error occurs, we will call countdown inside the onError function. Similarly, in the onCompleted function, we also write a log and call finishLatch.countdown. At the end of the uploadImage function, we call finishLatch.await to wait for the response thread to finish. Here we only wait for at most 1 minute, which is more than enough because above we set the deadline of the code to be 5 seconds. Next, we will create a new file input stream to read the image file. If we catch an exception, just write a severe log and return. Else we get the image type from the image file extension. We build a new image info with the laptop ID and image type. We create a new uploadImage request with the image info. And call requestObserver.onNext to send the request to the server. Surround this with a try catch. If there's an exception, we write a severe log. Call requestObserver.onError to report it to the server and return. Finally, we call requestObserver.onCompleted. Inside the try-catch block, after we have sent the image info, we will start sending the image data in chunks. Each chunk will be 1 kilobyte. So we create a new byte buffer with a size of 1024. We use a while loop here to read and send data multiple times. I will need to pull this file input stream variable out. Then here we can call fileInputStream.read to read more data into the buffer. It will return the number of bytes read. Assign it to n. If n is less than or equal to 0, then it's the end of file. We can safely break the loop. Now we check if the latch has already finished because of some unexpected error. Then we don't need to send more data. so just return. Otherwise, we make a new request with the chunk data. Here we just copy the first n byte from the buffer. Similar as before, we call requestObserver.onNext to send the request to the server, and write a log saying that the chunk with this size was sent. That's it, we're done with the client. Now let's run the server. And run the client. The image is successfully uploaded, and we got this response with the image ID and image size. The logs on the server side look good, and we can see the laptop image inside the img folder. Now, let's say we want to put a constraint on the maximum size of the image. For example, only allow upload images with size of at most 1 kilobyte. Then in the onNext function, before writing the chunk to the image data, we compute the current size of the image. If it is greater than the maximum allowed size, then we write a log, image is too large. We report the error to the client with invalid argument status and return right away. Okay, let's try it. Run the server. Then run the client. As you can see, some chunks are sent to the server, and we got an invalid argument error, image is too large. So it works. Note that the send part and the receive part are parallel, so it's totally possible that the client will send more than 2 chunks before it receives the error from the server and stops sending more. As a result, we will see a warning like this on the server side, because the server has already closed the stream when it sends the error to the client. Okay, the last thing before we finish. When we receive the image info, we need to check that the laptop ID exists in the store. To do so, we just call laptopstore.find laptop ID. If the laptop is not found, we simply call responseObserver.onError with status not found. On the client side, we can comment out this command so that the laptop is not created on the server. Alright, now let's run the server. And run the client. We got the not found error, so it's working as expected. And that's it for today's video about client streaming RPC. In the next lecture, we will learn how to implement the last type of gRPC, which is bidirectional streaming. I hope the course is useful for you so far. Thank you for watching and see you later.